Hello everyone, today I am going to show you how you can convert your Excel data to floor plans. And to do that we are going to use our Revit plugin InstaCrete 2.0. I will be covering Excel data to the Revit model in more details. Then I am going to talk about the floor plans and automatic tagging feature. Then we will see converting 3D model to analytical model. Next, I will show you how it's easy to edit the model using InstaCrete. As you can see, we are going to cover many things, so let's dive straight into it. In this Revit file, we can see a few foundations. These foundations are placed using this Excel file. Now, I am going to add a few more foundations. I have added those foundations in the Excel file. Let's run this Excel file. Let the row number be 8. Now let's run the file.
Hit the OK button. This message says, there are foundations on these grid points. Hence InstaCrete will not place new footings at these places. This means InstaCrete identifies existing structural members like footings, columns and beams and avoid those grid points to place the new objects. Helpful feature indeed. Here's another scenario you may come across. Let us assume that you are tackling a large project. You have very large Excel data. Naturally, to run such Excel files the system requires more time. In such a situation you can insert a blank row and run the Excel file step by step. You can see in this file I am going to insert a row after 17th row. InstaCrete begins reading the data from row number 8 and stops at row number 17. This way you can insert rows at small intervals. Then run this Excel file number of times to build a very large model easily. This means that very large models can be built by running the Excel files without any work in the graphics window. I love this! InstaCrete 2.0 comes with a new automatic tagging feature. So, whenever you build the model of the structural member, it comes with a tag. That means you need not run tag command separately. Not only you can add tags while modeling, but you can place them at a predefined distance and the direction. This can be done by using this new tag setting tool. This tool helps you to set the distance and the direction of the tag from the structural member. The result can be seen on any floor plan. The floor tag by default is at the center of the floor. For example, this tag states that this floor thickness is 250 and it is a sunk slab at a -25 mm distance. These are the column and beam tags. They show the size and grid position. Now let us observe this foundation plan. It comes with the grid lines, its dimensioning, footings and columns along with their tags. Hooray! I can draw floor plans while having a cup of coffee. Once the 3D model is ready you can convert that to an analytical model. Now you can use it for the structural analysis purpose. Once the analysis is done and you arrive at the final sizes, editing model with InstaCrete is a child's job. Let's assume that the footing size at E3 has changed. So to edit the footing, open the Foundation Manager. In the Select Grid box, type E, scroll down to E3. Change the foundation size and hit the OK button. InstaCrete does the job for you. Suppose that the column size at E3 has changed. Also, it has moved down the base level by 750 mm. This is the column tag before making any changes. Open the Column Manager. Select Base Level 1 and the grid E, scroll down to E3. Change the column size and type the -750 value. You can see the change in the column and foundation tags. Now, let us change the beam size on the 4th floor. The beam is located at the grid points E4, E5. Open the Beam Manager. Select the reference level as 4. Type E in the beam position box. Scroll down to E4, E5. Change the size. Hit the OK button. Open the 4th floor plan and observe the change. InstaCrete is a next-generation fully automated tool for structural modeling. The model is built by selection method. Hence, the time wasted while zooming, panning, copying, regeneration is saved.